All right. Hate to interrupt the discussions, everyone. But if you'd like to stay, please stay. If you'd like to continue, please go have some more open source fun. No worries. Today, I'm going to talk about tracing adventures from pull request to production. I am Paige Cruz, a developer advocate with Chronosphere. So if we can think about a typical scenario, like can I deploy? It's Wednesday, it's 4:30 p.m., and Dina, the developer, is ready to push out her code, get it deployed. She wants to make sure it hits production before the weekend and her sprint wraps up. But she runs into an issue where her pipeline keeps failing, and she figures she better ping the ops team. She pops over to the ops channel, says, hey, why does this deploy keep failing? Drops a link in and just lets them know I got to deploy this before the end of the day. And the first thing that all of the operator says is, have you tried rerunning the pipeline? Because that is the quick fix that addresses about 40% of the requests she's been getting. And Dina's like, yep, I've tried rerunning it 3 times. I really need you to look at this. Here's this big error message that it keeps spitting out. Maybe you can understand this. And so Olive's like, I'm a little annoyed. It's 30 minutes before the end of the day. You're writing to me about this really urgent issue. And support's been pretty tough this week. I've been getting a lot of requests. There is some flakiness. I'm ready to log off. But she just thinks that. What she writes back is, OK, I'll take a closer look at that. And what Olive is left with is a link to a failed pipeline, a big, hairy error message that is sort of devoid of any other context. And her team's alerts channel are silent. It doesn't seem like there's an issue with auto-scaling or node capacity. She checks to see if other pipeline runs have been successful before and after Dina's changes, and yes, they were. So she suspects that Dina introduced some misconfiguration or maybe a bunch of extra tests that are really expensive. She really thinks the onus is back on Dina, but just doesn't have the data to prove it. And she just thinks, why is ops always the one to, why does the buck stop with ops? And so to speak in really generic terms, right, both developers and operators use different telemetry, different data to understand the health of the same system, and they've got different responsibilities as a part of that system. When it comes to CI/CD, that typically is the place where we have the least observability, and it's sort of the environment that looks a little bit different than the rest of ours. And when you're a developer and you're trying to get something deployed, you're really thinking in this, you're in the driver's seat, you're looking about one pipeline, one service, one repo, really trying to get one change out the door. When you're in operations, you tend to take that helicopter view in the sky. You really care about all the pipelines, all the services in the repos, and you're mostly looking at the infrastructure and making sure that everyone can get to where they're going. You're not necessarily concerned about one particular pipeline. And so in situations like this, without sufficient observability and data to back up who you think, if it's your change or the platform, you can end up playing the blame game. And I think it's the platform is becoming the new it's the network, because it's very, very easy to blame things on a platform. And then operators, it's always easy to fire back up. It's your change. You don't know what you're doing. And we kind of get into this tug of war where both parties kind of think they're right, but we're maybe not. They're kind of talking past each other. And so to borrow a concept from cloud computing, sort of the shared responsibility model, when it comes to our CI/CD system, both developers and operators work on the same system. Operators provide a platform that developers use. But we've got a little bit of different things that we think about. Developers need to write application code, test, linting, formatting, all that good stuff. They're generally responsible for their deployment pipeline configuration. They are the expert for their stack. And of course, they've got to deploy their changes. While over in ops, we care about the infrastructure, nodes capacity, the network, and we're generally concerned at a higher level about availability, reliability, and these days, the cost efficiency. But that big gray line in the middle that has kind of openings, a lot of problems can seem like they fall right in the middle, and it can be really difficult to disambiguate who is responsible for solving what problems. And even then, if we double click into what developers are responsible for, well, who's really responsible for the duration of a pipeline? What if the build pipeline's been taking forever and you can't really trace it back to one commit that introduced that latency? What if multiple teams are sharing the same repository in the same pipeline? Who's responsible then? All of these questions in sharing responsibility for the same system really comes down to, do you have the data you need to kind of prove that your part of the platform is innocent or guilty? And do you even know where to start optimizing or starting to tackle these problems? So let's consider the path to production. So if we'll start with you opening a PR, typically these days you've got automated PR checks that run in pipelines. You hopefully have a human that's reviewing your code, making sure things are looking good. We've got the merge event, and then we've got a bunch of different deploys to however many environments you've got. You definitely have a production, and then it's sort of whatever your organization has for pre-production environments. And at any step in the way, something can blow up, something can go wrong. It could be a factor of the change itself. It could be a factor of the platform or the infrastructure being unreliable at that particular moment in time, or it could be a lovely combination of both of those things. And what you end up doing is playing this really awful game of spot the difference. What's different between this production deploy and staging? What's different between staging and integration environment? And the one that we're here to talk about today is what is different about how my pipeline runs versus what is going on in my later environments. So on some level, we kind of talk about environments as sort of the destinations that we deploy to, maybe like an integration. I've seen this first environment called acceptance. Everybody's got their own flavor. You probably have one more, and then you've got production. But when you start debugging things, you kind of figure out there's a couple more that sneak in there that aren't considered traditional environments, such as local development. That is one where dev and ops are totally far apart. I do not ever want to have to learn RVM or RBEM or whatever. I'm used to supporting so many different types of technology. I can't be an expert in all of them, and I can't set up my machine for everything that my company supports. So I like things in Docker containers or Podman containers or whatever. So that's one big difference. And then the second, with the PR environments, wherever your pipelines are running, it may not look anything like integration, staging, or production. And this sort of gray zone is where a lot of time is spent debugging what makes this different than everything else that's been working fine. And so what we want to do is bring people together, and my hypothesis is that tracing can be the data where developers and operators can share, look together, and collaborate. So let's talk about tracing together. And I hear you, or I can hear, I ask myself this as well. But we have metrics and logs. What's wrong with that? And it's not that there's anything wrong with that. Those are such workhorses of observability. They're not going anywhere. But metrics are great for monitoring. Metrics are great for telling you, did this pipeline fail, yes or no? How long did this pipeline take? They're great for checking thresholds and alerting on, maybe your company's we don't think builds should take longer than 20 minutes, and if they do, that should be an email that goes to the team. Awesome, that's not going anywhere. But what happens when you see, I don't know, a bar chart that has five instances of a pipeline that failed? You kind of want to know why, and that metric chart's not going to tell you, unless you've just put a ton of labels on there, which I kind of highly doubt. So normally, you're like, okay, I see the metric chart, I see something's gone wrong, but what is it? Let me go to the logs. And then you're scrolling through all of these logs that may or may not be formatted and trying to hunt down what is causing the issue that's causing the metric chart to spike. And what I'll say is you're still going to be using logs to troubleshoot, and you're still going to be using metrics to monitor the experience, so why even add tracing? Well, a lot of the platforms I've worked with for CI/CD and a lot of the vendors, they do try and provide this sort of out-of-the-box experience. We will tell you about the system health. We will tell you about the pipeline health. They've got these dashboards and charts. And the thing that is missing is linking that information to like the specific pipeline runs. And so I myself have struggled to answer some of these really basic questions like, were all runs failing on the same step? Have we seen an increase in Docker build times across the system as a whole, or for a specific team, or just for the folks that are using Ruby? Or, wow, we just upgraded the node pool for half of our nodes that run CI/CD. How is that working? Was there performance gains? Were there not? Like, you kind of just want to know, is it affecting everybody, or is it affecting just some people? What do they have in common? And the beauty of tracing is that it shortcuts. It scopes down, like, where do you need to look so that you can go to the logs with a really clear scoped focus. And so what is a trace? If you have not seen a trace before or are familiar with distributed tracing, welcome. A trace is a directed acyclic graph, which kind of just has a bunch of relationships between a series of activities. You can see the operation chart over there, and then the more traditional like waterfall flame graph view over here. And a pipeline execution actually is like kind of like perfectly modeled with a trace, because we've got a bunch of different stages that are going in sequence. And then each of these stages themselves have a bunch of different steps that run. And it'd be really cool to know not only how long did my build step take over time, but also if we noticed it was slow, why? Which step of the stage was taking a long time? If your pushes are taking a while, like, oops, that's the ops team, like, you probably need to figure that out. But if it's the image build, that's like, okay, developers, let's have a conversation. Like, what are you putting in your container files? Or maybe you're looking at the Docker engine as well. So when we look at that pipeline as a trace waterfall, you can start to see the power of like the waterfall visualization versus like a bunch of logs about what happened with timestamps. And if we're looking at this chart, you can be like, okay, what's taking the longest time? Scan image. Security added scanning images a while ago. I know we've had it for a while, but what is making it take so long? Why is it taking so much longer than even running our unit tests? That seems funky, right? So you'd want to ask a lot of questions, but it's because you were able to kind of see where the latency was. And so that was a simple example. Borrowing from Jenkins a traced, more realistic like Java pipeline, you can see that this data gets really dense. A lot of stuff happens as it happens to get code built and deployed. And like for me, the beauty is in the trace visualization. What's happening here? I want to know. I click. And with the span detail tabs over there that has like attributes like branch, build, Git version, you know, sort of all that helpful data. You can also put logs, links to logs in there. It's as simple as like kind of clicking to get more detail. And when you've got enough, collapse it and keep going with your investigation. It's really the like zoom in, zoom out, high level ops view, specific developer view. And while like what I'm talking about is tracing the pipeline execution themselves, like definitely helpful for developers, still helpful for operators. If you have like rolled your own CI/CD system, or perhaps you're using an open source one, then you are really more curious about like what it's doing under the hood when you've got a webhook that's like, we need to trigger a pipeline. You probably got to schedule that container somewhere. Maybe you're running a bunch of containers in parallel per step. And you want to know, maybe it's taking a long time to schedule. Maybe you decided to have spot instances to save money, but like actually that's adding a bunch of latency. Like you won't know until you sort of have this workflow view. And so when we're talking about tracing pipelines, what I would love, right, is like the full story from PR merge to production deploy. However, traces as they are today, that would be a very long trace assembly window because the way that you get a trace is by emitting a bunch of spans, which are essentially events that say, hey, I've got a trace ID, this is who I belong to, oh, and this is the ID of the span that was right before me, so you can order them. And so you send all those spans to like a collector or something like that, and they need to get assembled into a trace. So if it took like, I don't know, 5 days from PR check to production merge, you would be storing a lot of data in your collector. You would not want to pay for that. And so what you'll get instead is a trace for the PR check pipeline run. You'll get a trace for the deployed integration environment to staging and production. But just because these are distinct traces, it doesn't mean that that data is not related. As long as you've got a common attribute like a commit SHA, you will be able to trace how long did this take and sort of query all of those span events, those span/events, to stitch that story together. So as much as I think it would be lovely to have like the full story, like this is where we're at with tracing today. And like the thing that people like love about tracing, and the thing that they say a lot, is that you can slice and dice by arbitrary dimensions and data. And like, what does that mean in practice for us trying to observe developers pushing code out the door so end users can use it? Well, like we've talked about, operators really need to quickly know, is it you? Is it your team? Is it this repo? Is it this service? And a lot of the out-of-the-box like vendors or programs are really focused on like the singular pipeline point of view. It's a little bit tricky to get like the operator's point of view that you want. Another good one is like, was this data pulled from a cache? So many times I've wasted, oh my gosh, I wasted a lot of time chasing something down that just turned out to be like bad data that got pushed to a cache that affected all these other pipeline runs, and all we had to do was clear it and we were fine. But like having like cache hit yes on a span might be able to help you figure that out sooner. And so like the types of questions that we can ask when we've got tracing, the ones that I find really interesting are developers needing to rerun pipelines as a course of normal work? You could check that by seeing how many times a pipeline for a specific SHA had to run before it was successful. And if you start to see that like multiple runs of that pipeline have a one failed, one success, like you probably should be looking at that. Is it which pipelines, which teams? Is the pipeline running slower than last month? Great, yes, you get that from a metric, but your next question is why? Where will you find the why? In a trace. Another interesting one is sometimes we use vendors for like, I've seen some calls made out to vendors for parallelizing tests on a bunch of different containers or a bunch of different nodes. Or, oh, we're going to call someone to do a smoke test, or we're going to call like Twilio to do some stuff or whatever. Like when you've got an external API call that's like not just like running your code and running tests, you can also send what's called baggage kind of across that API call to at least get how long, the timing information for how long it took to complete that API call or request. And then like from the like cost perspectives, like you can take a look at how often people are deploying, at what times. Would spot instances help you? Should you just get bigger nodes? Should you ask the developers to just optimize their stuff? Having this data and being able to quickly ask and get answers can help you inform your decisions later on. And so you're excited, you're ready, you love your metrics, you love your logs, but you want to see this tracing thing in action. The way that you do that is through openTelemetry, which if you have not heard of it, it is, thank God, the open source instrumentation standard that is not just scoped to traces. We now have metrics. We can take in Prometheus metrics, and logs are, I don't know if logs are experimental or if they're still being formed, but like logs are on the way, I promise you. Having worked at, this is the third observability vendor I've worked at, I cannot tell you how excited I am to just have everybody instrument once and observe anywhere, like huge. I do think I would love to hear about like the infrastructure side of the house, because I definitely think openTelemetry has its space in software and the application layer a little bit more than infrastructure. But like instrument once, observe anywhere, it's backed by the CNCF. And really critical to note is they scoped down what openTelemetry is responsible for. It is actually not a backend, and it is actually not a UI. It is literally the framework and pipeline for sending, processing, transforming, and exporting telemetry data. You've got to bring your own backend, and you've got to bring your own UI. There is an open source UI called Jaeger for tracing, which is pretty lovely. And at a high level, you can kind of see the big component here is the openTelemetry collector, which is sort of the beating heart of OTel that can take in, process, transform, sampling, although I wouldn't totally recommend you sample your CI/CD tracing data, because you do kind of want to have all of that, and it shouldn't be that voluminous depending on how many people are contributing. But you can see you can also grab stuff from Kubernetes and cloud providers, and it all goes into you bring the backend, but OTel can provide everything else. So like very simple, the data flow would be you either have an openTelemetry SDK, an integration, a plugin within your CI/CD system that's generating spans and sending them. They'll send them to a collector, asterisk, because some observability backends have their own openTelemetry endpoints that take in OTLP, which is just the protocol for how we send this telemetry. But you generate and send, you process and route, and then store and visualize. And so your choices for instrumentation are always DIY or manual or automatic. And in this case, DIY instrumentation would mean kind of wrapping your build script or wrapping the steps in your pipeline with, there's one little binary, the OTel CLI, which is fantastic. And then I recently just found trace pusher as well. So that can get you sending your spans, but if you are using something like PyTest has its own tracing library. So if you wanted to detect flaky tests with Python, I would totally recommend going to the OTel registry, finding your stack, and seeing what like already instrumented libraries are out there for you to just pull in as a dependency. And then bring your own collector and backend. And so like, what does this look like? Grabbing from the trace pusher example docs, you got to know where you're sending the data, so you got to specify that collector endpoint. And then the key things to hit are you need a start time. Timestamps are super, super important in tracing. It's how we order everything. You've got to, so you've got your timestamp, you've got to send it, and then there's a bunch of environment variables so you can make sure that you're naming things right. And the other key piece is the duration and trace ID. So you actually, when you're rolling your own, you do need to bring your own trace ID and kind of generate that to get passed along. That is how all those spans know they're a part of the same family. Great. So before, we're like, hey, this is what time it is when we're starting the build step or the git clone step. You get your start time, you get your end time, and then at the very end, we want to make sure that we complete that span. And at the end of the pipeline, okay, so we'll go back. So this is like kind of your setup. Get your timestamp before, get your timestamp after, down in your build pipeline, do whatever you need to do. And then you have to push the trace. And this is the part where if you're using like a pre-instrumented library, you want to make sure that you're flushing those spans at the end. You probably want to have an explicit call there just because of the variable length that pipeline steps can take. Great. But if you are swimming in the warm waters of integrations, oh my God, I think it's so cool. Ansible now has a tracing callback, so you can get a trace generated from a playbook run, which I would have loved when I was starting out. Maven, there's a Maven extension, so you can send your Java build information out, and I mentioned PyTest as well for the flaky tests. I know there is a flaky Go test library that's already out there, and I would not be surprised if there are others that I just did not find in my research. This is the openTelemetry registry. Highly, highly recommend you check it out if you're curious about kind of plug-and-play instrumentation. These are all of our languages that are supported, and you can just see there is a whole buffet of things that are already to go, built by the community. And then the things that I was really excited about, because I first heard rumblings of tracing CI/CD pipelines like 3 or 4 years ago, and I thought, that's a great idea. I want to see what happens with this. And a few years later, we've got an official Jenkins plugin. Oh my God, making it super easy for you to get started if you use Jenkins. There's a GitHub Actions step. And then as far as tracing the platform and the pipelines, if you use Concourse CI, there's already experimental support for OTel. And of course, that open infra, got to talk about Zuul. There's a currently active proposal to implement OTel tracing that has a few nuances for how Zuul runs that I think would be really interesting if you are a Zuul user. Weigh in, give your opinions, join us. The more we can observe this part of our software lifecycle, I think the better. It has been neglected for far too long. And like literally active right now is an openTelemetry proposal to formalize semantic conventions specifically for CI/CD observability. I suspect when this OTEP is accepted that we will start to see a lot broader adoption from different CI/CD vendors and CI/CD systems now that there will be sort of like, this is what we've all agreed on is important to include as attributes. And so if we go back to sort of thinking about how can tracing data facilitate better collaboration between developers and operators, let's just think about the difference in responses you'd get if you saw that pipeline that we had up that had that really long security scan step. If you just dropped by the security team and were like, hey, this thing is taking forever, this sucks, like when is this gonna be fixed? Thanks for securing stuff, you're probably not gonna get a great response versus doing your homework and bringing some data with you to say, hey, security scans are taking forever. You can still kind of have the frustration there, but bring your data. You could say, it's been adding 15 minutes to every deployed pipeline, and there's 30 people committing to this repo. We're all in the same time zone, so we're stepping over each other. And because we only release one change at a time to environments, our queue length is so long that, that it's been taking over an hour to get changes from integration to staging. Boom, business case, data, you could send them some traces if you wanted them to get started investigating, but you're using the frustration that you feel that is totally valid about these long-running builds, but you're using the data to drive the conversation versus just the frustration. And so like, this is why I think that tracing has the potential to facilitate better collaboration because both sides can bring data to the conversation. It doesn't solve your ownership problems. It doesn't solve being understaffed or overworked. But I do think when you can raise the business case, a lot better outcomes are in store for you. So thank you very much. I'm on Mastodon on the Hachyderm instance. I have an email if you like that. And I've included a few bonus contents on my site, pagerduty.com with an I. You can get these slides and everything's clickable. Awesome, awesome podcast episode, kind of diving deep into OTel and CI/CD. GitLab has published a ton of information about their year-long effort to add openTelemetry to their GitLab CI pipelines. And if you're like, why is this important? I have a whole story about how a one-line config change meant to structure logs for traffic ended up causing a Sev1. That would have been super handy to know with tracing because it only blew up in production, not anywhere else along the path. Nope, we will not play that video. It is very long, but thank you very much. But seriously, like making the last talk of the conference, you guys are impressive. And if there are any questions, obviously, I'm here. I can answer them. Do you think tracing has a place in observing CI/CD pipelines? Do you struggle with understanding why things are slow? Yeah. 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 I mean, I think tracing is the answer, but I have also been called an openTelemetry purist, and so I'm trying to break myself, trying to say, okay, tracing is great, but it's not the whole universe. What can we realistically expect by taking the big effort that it is to instrument with traces? But honestly, if you just kind of like wait a year, wait 6 months, I have a feeling there will be a lot more plug and play, a lot more integrations that are available, so you won't have to do all of that, like creating a trace ID and making sure you're flushing everything. The goal, at least with OTel, is that you don't really have to think about that instrumentation, only the instrumentation for the custom components that you're writing, which would be awesome. So, yeah. Thank you, thank you.